Hello and welcome back. I'm Sean with Bacon and Games, and this is video number 6 in our Snake Code Along series. If you're just joining us, there are links to the previous videos in the description down below. In this video, we'll finish our game by adding a HUD and a save system for tracking high scores. If you've made it this far, please consider subscribing to the channel. I've got a line of videos coming up based on my 7+ years at indie publisher Armor Games Studios, talking about the business of making games. Everything from how to approach a publisher, how to prepare for industry events, marketing, well, maybe not marketing, but also how to manage scope, productivity tools to keep you on track, and a whole lot more. So if you're looking to turn your game into a business, please stay tuned or hit that bell for notifications. And with that shameless self-promotion out of the way, let's finish this thing. We'll start by creating a new script to manage our saved data. We'll go to Create New, Script, and this one's going to inherit from resource. Let's call it Save Data. We're extending from resource because these can be saved to disk. This video is influenced by game dev Artisan's tutorial on saving user preferences. I'll drop a link below. It's worth checking out. Let's create an export variable of integer called highScore, where we'll save our highest score. Let's also define a constant called savePath with the path to the file where we're going to store this data. This user:/ is the default save location. The name you choose for the file doesn't really matter. We'll use Godot's built-in singleton, the resource saver, to call the save function, passing in this class, including our highScore variable, and the path to where we want to save the file. Let's create a new static function called load_or_create that will look for an existing save file and load it, or if one isn't found, it'll create a new one. We're going to make it a static function because that will allow us to call load_or_create directly from the save data class rather than having to create an instance of it to call that method. This is all we need to do for our save data file. To make sure that this save file is always available to us, let's come into our auto-loaded global file, create an instance of save data called save data, and in our ready function, let's call savedata.load_or_create and store it in save data. This will ensure that the second our game loads, it will either pull down our saved file or it'll create a new one if this is the first time the game has been loaded. This is also all we need to do in our global file. Now, if we come over to our start screen, where we had previously hard-coded high score, let's access our saved data. If we run the game, this shouldn't look any different because we don't have a high score yet. However, just as a quick test, we can set and save a new high score value, reload the game, and we'll see that it's now there. Running this will fire our temporary test code, and now if we reload, there's our high score of 10. To clear that out, we can come up to Project, open user data folder, and find our save file, and delete it. This will reset our high score to 0. Let's clear out this test code and add some logic to our game over screen to detect for a high score and save it if we set a high score. First, we'll check whether our score is greater than our high score on record. If it is, we're going to make sure that our high score display is visible. We're going to save this score in our high score variable, and then we're going to call save. If, on the other hand, our score is not a high score, we're still going to set our final score text, but the only other thing we're going to do is hide our new high score display. Let's test this out. As expected, our high score is 0. I'm going to collect 1. Now you can see our final score is 6, and we're getting our new high score display. If I restart and crash after 4, we're not showing our new high score, but we do see the correct final score. Let's quit and come back into our game over screen and make our panel a little bit darker because I think that final text is a little hard to read. And that's all we need to do to save our high score. But the player still doesn't know what their score is while they're playing nor do they know what the high score is that they're trying to beat. So let's create a HUD to display that information while we're playing. Let's create our HUD by going to Scene, New Scene, choose Other Node, Canvas Layer. As we've done before, we're going to add a panel. But this time, we're not going to set it to full rect. We're going to set it to top wide. Let's add an H-box. Also set it to top wide. And instead of begin, which will push items to the left, let's set it to end because we want our scores in the upper right-hand corner. Now we can add two labels. We'll default it to score:0, duplicate it, call this high score, and set this to high score. For consistency, let's set our color to something in the orange range, our high score color rather. And because this is looking a little bit cramped to me, let's add some margin containers. Let's select Theme Overrides, Constants, and put a little bit of padding on the right. And for our high score, just so it's not touching the right side of the screen, we'll give that a little bit of padding as well. This will give us a transparent HUD. If we want the HUD to be an entire bar, we can give it a minimum height of 32 to make it fit nicely in our grid. With a visible background, now our text is no longer centered vertically. Let's select our margin containers, come back into our constants, and add some padding on the top. There we go, that looks pretty good. Let's name our layer HUD and save this in our menus. Now we can go back into our gameplay scene, click the link to add a child scene, search for HUD, and add it at the bottom, which is where we want it because we want this to be on top of it. Now if we test our game, you'll see that our character does move under the HUD as expected, which might be what we want. However, this is a good opportunity to demonstrate the value of our bound system. If I don't want the character to show underneath the HUD, and I don't want food to spawn there either, we can simply grab our bounds, grab the upper left, and move it down one grid position. Now if I replay the game, you can see we wrap just at the HUD. All right, let's finish up our HUD. We'll go back in here and add a script. Let's give it a class name, HUD, unsurprisingly. Get our references, control release, and in our ready function, we can set our high score text. Now we're showing our high score of 6. Great. We don't need our process function, but we do need a way to update our score as we collect food. Now we can go back into our gameplay, grab a reference to our HUD. Let's remember to cast it to HUD. And every time we update our score, let's reference our HUD, update score, and pass in score. Now when we play our game, every time we eat a piece of food, the HUD updates. Okay, we are almost done. Before we wrap up this video series, I want to do a little bit of cleanup, and I also want to refactor this so that we can make use of a getter and setter function. We don't really need it, again, because this game is so simple, but in a more complex game, this design pattern is really helpful. So let's take a look at getters and setters. If I scroll back up to my score variable, instead of setting this 0 here, I can add a colon and add these two sub-definitions. This is our getter, which is the same as accessing that variable directly. It simply returns its value. And this setter function, which will accept a value, same as doing score equals whatever number, but then every time we set the score, it's also going to call our HUD.updateScore. And this is powerful because you won't have to remember to call HUD.updateScore every time the score changes. Imagine that this game also randomly spawned bonus items that only lasted on screen for a few seconds. If you collect them, you might get more than 1 point. When you do collect those, you'll be updating the score in more than one place. And then you would also have to remember to call HUD.UpdateScore. In this case, you can simply call score plus equals whatever value, and the HUD will automatically be updated regardless of where you call that from. Now that we've set up our getter and setter, we can come down here and we actually no longer need this line. Let's test the game again. And even though we're no longer calling that after updating our score is still updating in the HUD because our setter is now handling that for us. Before we finalize our game, let's do just a little bit of cleanup. I'm going to go back through and remove all of our print references. I'm going to tidy up some gaps. I generally like to have all of my variables together. So let's move these down here. I had paired them in that video with the constants so that you could see that relationship. I like to have my constants at the top, my export variables next, my onReady variables, and then all the rest of my variables at the bottom. It's sort of a logical order of operations for me. Constants are what they are, preloading happens first. The export variables, in my mind, happen before the onReady because you're doing them in the editor, then the onReady's fire, and then your garden variety variables are stood up at the end. Again, you don't have to do them in this order, but I find it calming to have everything neat and tidy. Lastly, let's clean up our ready function. I'm going to put a space here to separate this code from all of my signal connection code, and I'm going to change this up just a little bit. First, I'm going to add this line of code here that will essentially force our snake to start moving immediately rather than waiting one full tick before it moves. And I'm going to get rid of that space and save. We could go through the rest of our files to do similar cleanup, but I will encourage you, when you follow along or take this project further, to find an organization system that seems logical and comfortable for you. With that, we've got a fully functional game with a score, a high score system, a pause menu, a way to restart, and along the way, we've covered more than a dozen common fundamental design patterns in Godot. Thank you so much for sticking with me throughout this entire series. I am probably going to drop one more video. For now, I'm going to leave that a little bit of a mystery, so please click that subscribe button if you're interested to see where we take this project next. As always, I truly appreciate your time, and until the next video, be kind to yourself and be kind to others. Take care.